because we don't have passing opportunities and one direction affects the other. And we discussed the base conditions. What else? Yeah, where can you use them? What type of segments we can have? Okay, passing constraint means passing not allowed because no sight distance. Passing zone means passing allowed because of sight distance. And climbing and passing lane means passing allowed with the extra lane you have. Okay, discuss access points as well. We have discussed it earlier. Now we are moving on to performance measures. Okay, how do you measure the performance of two-lane highways? So performance measures are those things which will give you the level of service in the end. Okay, performance measures are, we call them service measures as well. They are the same thing. Performance measure and service measure is the same thing. The thing which you need to calculate the level of service. So my question is, if I want the level of service for freeway, what is my service measure? So if somebody is asking me, give me level of service of this freeway, what I should have or what I should calculate to give him the answer? Density, yes. So when you have density, you can calculate the level of service for a freeway. Like not calculate it, just take it from the table. Similarly, the level of service for two-lane highways requires three things. Okay, and the fourth thing is mentioned because you cannot get these three without the fourth one, free flow speed. The free flow speed is like the default. You will not use it for level of service, but to calculate the remaining three, you need free flow service. So we have the average speed, we have the percent followers and percent follower density. So now you see the term follower here, okay, and we are not talking about Instagram followers, we are talking about traffic followers. So Bayan, you are having problems again. Okay. Anyways, so what is a follower? Who is a follower? If two vehicles are going in the traffic stream and the headway between them is 2.5 seconds or less, so this is called a follower condition. Okay, between two vehicles, if the headway becomes less than 2.5 seconds, it is called as a follower condition. Okay, so in this condition, the vehicle behind is strictly following the vehicle in front. So brake of one vehicle, brake of the first vehicle means brake of the second vehicle. If it doesn't happen, it will immediately result in a crash. Okay, so following condition, one driver has to follow the other one to avoid the crash in terms of speed and braking and so on and so forth. So percent follower means how many of these cars in the traffic stream meet this condition, 2.5 seconds or less headway, how many of them? And then density is, density is vehicles per mile. So in 1 mile, how many of the vehicles are in the follower condition? Okay, so percent follower means what percentage of cars are in this condition, the following condition. And follower density means how many cars in 1 mile are in this condition. Okay, so they are depending upon each other, and later on you will see that I am calculating density from percentage. Okay, but you understood the concept of the follower. Okay, any questions? Everybody understood what is the follower? Okay. So this this table gives you the maximum capacity of a segment which has a passing lane. The maximum capacity of a segment which has a passing lane. Any other segment, the capacity is fixed as 1700 vehicles per hour. So this is for passing constraint segments, and this is for other segments which are not passing constraint. Okay. So it depends upon percentage of heavy vehicles and depends upon vertical class. Now this is not gradient. These values are not gradient. These are classes. Okay, so 1 means 1, not 1%. How did I get 1? Or which segment has 1? There is another table for that. Okay, so this 2-lane highway has a lot of tables. Some of them we will cover, some of them will not cover. Okay, but it has a lot of tables. If you go to highway capacity manual, you will see lots of tables, maybe 50, 60 tables in the whole analysis. We are not going to cover all of them. But going back to the point, these are not percentages, these are codes 1, 2, 3. Okay, not 1%, 2%, 3%. And they only apply to segments which have a passing lane. If the segment doesn't have a passing lane, then this is the capacity. Okay, these two tables give you the level of service for bicycles and for cars on 2-lane highways. Okay, so they depend upon follower density. Okay, follower density. So still it's density, but follower density. Okay, for bicycles, we use a score which is called as bicycle level of service score. We are not covering it in this course. If you have seen in the previous chapters as well, we haven't covered level of service for other modes of transportation. We are just covering them for traffic. So we are just dealing with this table only. Okay, so level of service depends upon follower density. It has two ranges. One, or depending upon the speed, posted speed of the segment. Posted speed is 50 or more, you will use these ranges. If it is this one, then you will use these ranges. There is no nothing given for level of service F. Okay, so how do I find out level of service F? I check with the capacity how much flow rate I have, and if the flow rate exceeds capacity, I have level of service F. Okay, so for example, I have follower density 13%. So according to this range, my level of service is E. If it is 14%, still E. 20%, still E, because there is no maximum here. So anything more than 12 can be any value. It will be level of service E. So there is no limit which exceeds E for 2-lane highway. There is no maximum of level of service E for follower density. Okay, so the only way to check if I have level of service F or not is to compare my demand with the capacity. Okay, and this is what we should do first before calculating the follower density, because if demand exceeds capacity, your level of service is F. Density doesn't matter. Okay, density in that case does not matter. Okay, what data we need? We have used lane width, shoulder width, access points, posted speed limit, something which is additional here, passing zone. Okay, passing is allowed or not in this segment, and in some cases the segment can be partially passing allowed. So you have 1 kilometer, out of 1 kilometer only 500 meters passing is allowed. So you can have a percentage of the segment in which passing is allowed. You need the vertical gradient, you need the horizontal curve, and you need the, if there's a passing lane, then you need the length. Okay, if there's a passing lane, you need the length. You need the volume for your direction as well as the opposite direction. Now, if you remember, in the case of multi-lane highways and freeways, we are only using one direction. Here we are using both directions because they affect each other. Okay, they affect each other. What is the length of the analysis period? Normally 15 minutes. So that's why we calculate the flow rate. Okay, use of flow rate means we are dealing with 15-minute period. although we are using per hour, but you know flow rates are 15 minutes. You need the peak hour factor, you need the heavy vehicle percentage. Okay. Some of these values have default values. Some of these parameters have default values, which you can see over here. Okay. For some of them, there is no default value. You have to get it. Okay. So you cannot assume. For these parameters and these ones, they can be made, an assumption can be made. For the others, no. Okay. Very long procedure. It has 11 steps. Later on, you can zoom in. I'll directly go to the real process. Okay. So we have discussed earlier about the vertical class, right? Okay. So vertical class affects the capacity of segments which are with passing lane, right? So vertical class also affects the length of the segment. Okay, the length of the segment. So vertical class 1, minimum maximum length is given with passing constraint, passing zone, and with passing lane. Okay, I already explained what we mean. So you can determine the length of your segment according to its vertical class. Okay. Second thing which we need to do is convert the volume to flow rate. The demand will be given in terms of volume. You convert it to flow rate. Now you see the letter subscript I here. I refers to the direction. So there are two directions. Okay, so you will do it for each direction separately. Okay, so I can be for your direction and the opposite direction. Okay, even just clarification here. If you are doing analysis only for one direction, still you need demand of both directions. If you need, if you are doing or you only want develop service for one direction, you still need demand of both directions. Okay, you will need it in the equations later on. Okay, so vertical class. This table gives you vertical class. Okay, so the numbers in the bracket I believe are for passing constraint segments, and the number outside the bracket is for other segments. Okay, so it depends upon the length of the segment and depends upon the gradient. Now, these are gradients. Okay, the values on the top are gradients. You can see grade in percentage. So this is 6 to 7%, 7 to 8%. And these are codes, vertical class codes, which you will put in this table and in this one. Okay, so percentage goes there and that table gives you a code. That code goes in the vertical class. So you can see most of the cases, the number inside the brackets and outside the brackets are same. Okay, but if they are different, then you will check passing constraint, use number inside the bracket. If it is not passing constraint, then you will use number outside the bracket. Now free flow speed can be measured from the field, or it can be calculated using these equations. So first of all, how do we measure free flow speed? How free flow speed is measured? I have asked this question earlier as well, and this is part of your term project. So how do we measure free flow speed? Yes, anyone? How do we measure free flow speed? Anyone? Yes. How do we measure free flow speed? No one? Okay, but There is a method of measuring free flow speed. You should know that. Okay, if you cannot measure free flow speed, I mean free flow speed from the field, then you can use these equations. So you can see down there are multiple equations here. You need one to calculate the other. So you start with the calculation of basic free flow speed, which is speed limit into 1.14. So SPL is speed limit. Okay. You look at the equation of free flow speed. What other parameters you need? You need heavy vehicle percentage, you need A, and you need these two factors. Okay. Factor, this is factor for lane and shoulder width. So this factor comes from this equation. LW means lane width, SW means shoulder width. Okay, so you calculate the factor FLS from here and put it over here. Then you have factor for access points. So this factor comes from here. Access point density, access points per mile, divide by 4 or 10, whichever is minimum. So if APD upon 4 is 5, okay, so you will put 5 in the equation. If APD upon 4 is 20, then you will take minimum, that means 10. So 10 will go in the equation. Okay, so then we have the A factor. Now A has this long equation, and that equation itself has how many factors? 5 factors. Okay, and then it has V naught as well. What is V naught? Demand flow rate in the opposite direction. V naught is demand flow rate in the opposite direction. So you can see here I need it for my direction as well. I'm calculating A for my direction, free flow speed for my direction, but I'm using V naught here for the other direction. Okay, so you need it. So again you will see you have to take maximum of these two and maximum of 0 and this and so on and so forth. Okay, we will see when we apply the equation. Okay, so this is how you will calculate the free flow speed. After you calculate the free flow speed, this is an explanation of the things which I already mentioned. Okay, then you calculate the average speed. After the free flow speed, the average speed. If you remember in the case of freeways, we had the same condition. Speed, average speed can be equal to free flow speed, or it can be coming from a equation. So you have the same thing here. Now this is flow rate in your direction, okay, not V naught. VD means your direction. So if it is less than 100, then speed equals to free flow speed. If it is more than 100, then you have to use this equation. And this equation M and P, we need two constants here. Okay, M is called the slope factor, P is called the coefficient, slope and coefficient. If you go to highway capacity manual, you will see maybe 3, 4, 5 tables to get these two factors. Okay, we are skipping those tables. If this thing comes in the exam or wherever, I will give you these factors. But keep in mind, these factors are coming from a series of tables. Okay, so they need to be calculated. Okay, but we are skipping the calculation of M and P. Okay, after you do that, then you will calculate the percent follower. Okay, so just remind me what a follower means. What do we mean by a follower? Yes, in terms of traffic, what is a follower? Yes, anyone here? Yes, go ahead.
Of vehicles passing.
Say again.
The percentage of vehicle passing.
No, what is a follower? What is called a follower stage? When we are in the follower stage? Okay, behind another, yes. How much behind another? There's a range for that, right? How much is that?
2.5.
2.5 seconds, yes. Okay, thank you. So what percentage of drivers are in the follower stage? This equation gives you that. You need VD, flow rate in your direction, and MNP. Now this MNP, and this is another confusion here according to SCM procedure, this MNP is different than the previous one. So this MNP is different and this MNP is different. Okay, so there are two sets of factors you need. One for average speed equation, the other one for percent follower equation. Okay, so again, this MNP also has a series of tables. So for the time being, we'll just assume that it will be given. But if you go to highway capacity manual, you will see the entire procedure to find out MNP using the series of tables. Okay, once you have PF, then you can find out follower density using this equation. Okay, so percent follower, it is in percentage, so divide by 100, multiply by VD, which is the flow in your direction, divide by S, which is the speed. It could be equal to free flow speed if VD is less than 100, and could be coming from this equation, VD is more than 100. Okay, so this gives you follower density. Once you know the follower density, you can go here and you can find out the level of service. Okay. Okay, let us go through this example together. Okay, the segment has these characteristics. Length is given. It is passing constraint. No passing lane. Vehicle count in one direction is given. Peak hour factor is given. Posted limit is given. Percentage of vehicles is given. Gradient is given. And what else? Curvature, there is no horizontal curve. Lane width, shoulder width, and access points are 0. Okay. Now we'll start with finding out the flow rate. Okay, so first step is here is the flow rate. So flow rate is you divide volume by the peak hour factor. So I'm doing VD only here. Okay, so this is 800, huh? Okay, moving on. The next thing is we calculate the free flow speed. For free flow speed, I need to calculate BFFS first, which is speed limit into 1.14. My speed limit is 50. Okay, so this is my BFFS. Now the other factors I need, percentage of heavy vehicles I already have. They have given it. I need to calculate lane and shoulder width factor and access point factor. Okay, access points are 0. So 0.4, 0. Okay, I have to take the minimum. So this is 0 and this is 10. Minimum will be 0. So FA is 0. Okay, access points are 0 on the segment. 0.4 is 0 and I have to take the minimum of 10 or 0. So 0. Then lane and shoulder width. If I go here, lane width is where is it? 12 feet. Shoulder width is 6 feet. Okay, so 0.6, 0.6. Yeah, 12. I'm just showing how it is 0. Okay, so obviously when you do this 12 minus 12 and 6 minus 6, you will get 0. So this factor is 0. FA is also 0. Now comes the A factor. So A comes from this equation. So I need A naught 1, 2, 3, 4, 5. For all these, I have this table here. Okay, this table gives me all the A factors, but to get them I should know the vertical class. Okay, my segment length is 0.75 miles and my my gradient is 0. So 0.75 miles and 0% gradient. 0.75 miles is here and 0% gradient is here. So my vertical class is 1. Okay, you can see it's 1. If I come here for vertical class 1, all the A's are 0. So from A0 up to A5, all of them are 0. Now if this is 0, this is 0, this is 0, all these things become 0, right? And then again A3 is 0, A4 is 0, A5 is 0, and you have to take the maximum of 0 and 0. Okay, you have to take the maximum of 0 or this whole thing, and this whole thing is 0 because all the A's are 0. Okay, so when you take out of the bracket 0 multiply by this, so this also becomes 0. Okay, so this bracket is giving you 0 multiply by anything will become 0. So this whole thing becomes 0. This is 0, this is 0, this is 0. So everything is here 0. Okay, now what will be my A value? Either this whole or either 0.0333. Okay, I have to take the maximum. Okay, so I will take 0.0333. Yes. Okay, everybody understood about the A factor here? Any confusion here? What do you mean? You have confusion or it is clear confusion? It is clear, yes. What are you saying yes to? Clear. Okay, very good. Okay, so now you can calculate the free flow speed. Okay, the free flow speed is the base value, which was 57. Then the percentage of heavy vehicles, which is 5% here. Okay, they have written percentage, so I'm putting percentage here. It's written here, percentage. Okay, and these two are 0. So how much is my free flow speed? Okay. Moving on, the next thing is my speed equal to free flow speed or this whole thing? Okay, my VD you calculated 800, so I'm here. So free flow speed must be calculated. Okay, I need M and P factors. As I told you, they need a series of tables, but for this example, I've already gone through the series and these are the M and P values. Okay, so my speed will be equal to speed equals to 56.8 minus M value 3.626 VD of 1000, VD is 800, 1000.1 to the power P. What is my P value? 0.41676. Okay, so this will give the speed. Okay, the next thing is you calculate the percent follower, which will come from here. As I told you, you cannot use same M and P value here. Okay, they are different M and P. Okay, so we have to look for another M and P, which are given here. They are coming from different series of tables. Okay, so PF is 100 1 minus e to the power m. Okay, what is my m value here? Minus 1.337. Then this multiplied by 800, 1000 to the power p, and p is 0.752. Okay, then I close all the brackets. Okay, so multiply with 100 after. Okay, so we have 67.71% who are in the follower stage, who are very close to each other. Okay, the follower density comes from here. Follower density 67.71 divided by 100 multiply by VD is 800, S was 53.771. How much is that? Okay, so follower density is 10 vehicles per mile. My speed limit was 50. So here 10 is this one. So my level of service is D. Okay. Now, before I have skipped one step here, which is the check for level of service F. What is the check for level of service F? Can somebody tell me? What should I have checked before moving on with the calculations? Anyone?
The posted speed limits.
No. Right, check the posted speed limit. It was given 50. I took it from here, but it has nothing to do with the level of service F. How do I check for level of service F? Demand exceeds capacity, yes. Okay, so my demand was 800 and the capacity for constrained segments is 1700. Okay, so it was not exceeding that. So what I've did is correct, what I've done is correct, but I did not mention it. Okay, so if your demand came out to be 1900, you will not do any further analysis, you will say level of service is F. Okay, moving on. Yeah, so there are other examples here, but they are in the highway capacity manual. Okay, one thing which I should mention, your textbooks are published before the new highway capacity manual. Okay, so they do not have the examples and calculations for two-lane highways in this way. They are still following the old draft, the old edition of the highway capacity manual. So if you try to look for examples like this in the textbooks, any of the textbooks, you will not find it. So that's why I have given you the page numbers from where you can find out the examples using this procedure. Okay, and that can only be found from the highway capacity manual. Okay, because the textbooks which are using is 2020 or 2021, even if it was 2022, this procedure will not be included because it was published in the same year. So maybe in the next edition of the textbooks, they will include it. If you want to stay in this course till that time, be my guest, no problem. Okay, Now I'll move on to the next topic, which is traffic control devices. These slides are taken from chapter 4 and 18, and they cover two silos. We will see some basic concepts related to traffic control devices, and we'll also try to cover the design of pre-timed signals. So later on, we will discuss different types of signals. In this course, we are only covering one type of it, which is pre-timed signals. What are traffic control devices? These are the media through which you communicate with the drivers. Okay, so anything which tells the driver about how to drive, that's a traffic control device, or which forces the driver to drive in a certain way. Okay, anything which informs the driver or forces the driver to drive in a certain way, that is a traffic control device. Okay, and we are basically trying to communicate with the driver through these devices the behavior which is safe and which is according to the road conditions. So there are three types of traffic control devices: traffic markings, signs, and signals. Okay, so the manual which we follow for design of these traffic control devices, called Manual on Uniform Traffic Control Devices MUTCD. It covers three main aspects: application of device, design of device, and placement of device. Okay, application means where should we use it, like in what situations should a device be used. You cannot use a signal in all situations. You cannot use a stop sign in all situations. So there are conditions which you have to look for before you go for a installation of a device. Okay, so this is covered in application. Then design. Okay, I want to put a signal. What should be the height of the signal? What light should be used in the signal? What will be the diameter of the light? Okay, and so on and so forth. So this is the design aspect. And then we have the placement. Okay, I'm going to use a signal on a pole. Where should be this pole? Should it be in the middle of the intersection? Should it be on the side? If I put it on the side, how high should it be, and so on. So this is the placement aspect. So this manual covers all these three aspects. The manual is published by Federal Highway Administration. The latest version was 2023, and it is used in many countries. Okay, they are using the same principles which are given in the manual. Now we have discussed earlier about highway capacity manual, which is also by the same organization. It's done in US. You guys have used ASTRO standards in some other courses, ACI standards in some courses. So why are we using standards from these countries? Why are we adopting it? The thing is that to develop these manuals, they have done a lot of studies. So what is given in the manuals is the result of those studies. So like I mentioned, the manual publishes new additions, values change, procedure change. Okay, but to make that change, they have done their share of studies. So they did not just come up randomly with a number and give us, okay, use this number now. No, behind that number there are a lot of studies. So we are trying to take advantage of their studies. And why most of them are US based? Because they are available. First of all, there are a couple of things here. When we are using US manuals, so US is a big country. It has a lot of variations of traffic and weather and drivers and so on and so forth. So their studies, when they do study comprehensively, they are covering all these conditions. When you take something from there, you can be more confident that it will apply. It will apply to your conditions as well. First thing. Secondly, they make it open source. Okay, so it is available. Thirdly, they do a lot of research before they come up with these manuals and these things. Okay, so like I mentioned, we are trying to take advantage of their studies. Okay, so this is about why we are using them. And why did they come up with a manual? Why should we have a manual for traffic control devices? This manual, you can see, it's not written here, but the first manual for traffic control devices is not so old. It was published 2010 or 11 or something. So before that period, nobody thought of a manual or a standard for traffic control devices. Okay, but later on, as the traffic increased uh, and people started traveling from one country to another country, in case of US, even from one state to another state, the laws and rules can change. Okay, so when these things happen and you let the traffic control devices be designed and placed in any way what people like, then there can be confusion when you go from one area to another area. To avoid that confusion, people are going for uniformity in these devices. So you have the European Union countries. Okay, you can go from one country to another country, maybe visit like 5 6 countries, okay, without requiring specific pass or visa or something. So you are freely moving from one country to another country and they are following different laws. So if their traffic control devices are different, you can have a problem. Same thing in US states, same thing in Gulf states for some of the residents. So that's why we need uniformity and that's why we need a standard. Okay, so as I mentioned, it covers three aspects. The application aspect, which is the number 3 here, warrants or conditions. Okay, things which you need to meet before you decide for using a traffic control device. Then we have the first one, which is the design. Okay, how the device should look like, the shape, size, color, what type of legends or symbols you are going to use in it, what will be the font size, and so on and so forth. Then we have the standards on the placement with respect to the road. Should it be on the road, on the side of the road, on top of the road, and so on and so forth. So these are things which are covered by the manual. Okay. Now this is again going back to the basics of traffic engineering. You are communicating something to the driver. Okay, so you should, and the driver is moving. Okay, so he cannot pay attention to each and everything. So you need to decide at what location what information should be communicated to the driver. Okay, because you don't want to distract him or her unnecessarily. He or she is already having enough distraction with the phone and with the signs on the road and whatever is happening around them. So you don't want to create unnecessary distraction for him or her. So for example, you are on a curve, on this curve the speed is already very low. So you don't want to put an extra sign or an extra camera there. It will be useless and just distract the driver. Okay, the driver is going at full speed, it's a main highway. You don't want to put any stop signs or yellow signals or something like this. Okay, it is something unnecessary. So first of all, you communicate the information which is important for the driver. Secondly, how would you communicate? You communicate in a way that it should catch the attention of the driver, and this is where the placement and the design comes into play. Okay, if you are not using proper colors, if your font size is too small, okay, it will not command attention of the driver. Okay, you did not place it properly, so it's a sign which says where to go for turning. Okay, if you take the turn, where will you end up? And you have put it at a very low height, far from the road. The driver cannot see it. So he is still looking at he is still searching for directions while your sign is already there. So he cannot take benefit from your sign. Okay. Another thing is, for example, you see the lane marking. Okay, the lane marking. The lane marking, with the passage of time, the lane markings get dimmed, and then they sometimes they can be completely erased as well. Okay, so those dim lane markings, which have now become very light. Okay, they are not serving any purpose. Okay, the lane markings which are very prominent, okay, with bright colors, they are very they command attention. That's why we use the lane markings in yellow and white. Any type of pavement marking is yellow and white. Why? Because with the background of the pavement, it catches your attention because of the colors. Okay, same thing with the color of the signal as well. Okay, the yellow catches less attention, and the red and the green catch more attention. Okay, so we have to use it in a way that it should command attention of the driver. It has to deal with the placement as well as maintenance as well as the design of the device. Then the message which you are giving to the driver should be very direct. Again, it has to deal with the timing. So the message says reduce speed. It's a command. It's a command. That's it. Nothing else. We don't need to inform the driver about the design of the road, that the gradient is this much and the radius is this much. Okay. And these many accidents happened on the road. We don't need to give all this information because he doesn't have or she doesn't have the time. Okay, so the message is a pure and clear command. Okay, it's a pure and clear direction. That's it. Okay, no more details. No more details. You will not find any road sign or signal or marking which has details in it. Okay, then it should command respect of the road users. Although you are not providing details, but if your device is providing some necessary information which the driver feels is required, then you command the respect. Okay, so for example, I gave you the example of the direction sign. Okay, so I'm looking for direction. There's an intersection ahead. I need to know where should I go, and you have this sign over there. Okay, similarly at the intersection you need the stop line as well. Okay, so I need to know where to stop, and I can feel that if I don't stop at a proper place, I can cause danger to other people, other drivers who are coming from the other direction. Okay, so putting a stop line there at the proper place and making it clear will command my respect. Because I am looking for it myself. Okay, so devices should be placed where the drivers are expecting it. Okay, where the drivers are looking for it, where the drivers are looking for that sort of information, it should appear in front of them, and this is how you command respect of the road users. Then the timing when the device becomes visible, that's very important. Because why are we providing the devices? So the driver can take some action. If your device doesn't become visible with enough time for that action, your device is useless. So the device is a stop sign or a stop line or a red signal. We know the driver, when he looks at one of these things, his car is going at 60 kilometers per hour. At 60 kilometers per hour, he cannot stop in 1 second, or he cannot stop like within 5 meters. So wherever he is supposed to stop, he should have enough visibility for the message to stop before that point. Okay, so this is what we mean by giving adequate response time to the driver, and this also again is taken care of by the design, the placement. So most of these things are related to design and the placement, commanding attention, conveying a clear simple message, and giving adequate time. These are related to design of the device and its placement. This one and this one, fulfilling a need and commanding respect, it is related to the application of the device. Okay, where and why you are providing it. If these things match the condition of the road and the expectation of the driver, you are fulfilling a need and you are commanding the respect of the driver or the road user. Because many devices are not for drivers, they are for pedestrians or bicyclists or passengers or something. A very important principle for communication is redundancy. Redundancy is a very important principle of communication. Whether you are communicating with the driver, whether you are giving a speech or a presentation, or whether you are giving a lecture, you have to make sure that you are providing enough chances, not one chance, enough chances to the listeners or to the audience to get your message. This is what redundancy means, giving more than one chance to the other party to understand and get your message. Okay, so for example, the color, shape, and pattern of the traffic control device. Okay, so now you can see a traffic control device over here which has a red circle. Okay, it has a red circle. So red circle normally means stop, right? You see the red circle in a signal, stop. But to make redundancy, they have put a stop word on it. So this is redundancy. Okay, a red circle and then stop written on it. Then you can do, so this is redundancy in the same device. The same device is communicating in two ways about the same message. You can use multiple devices for the same message as well. This is also called redundancy. For example, a traffic island which is separating a left turning lane, and then you see two signals, separate signals, one for left turning only and the other one for straight. So the traffic island and the lane marking and the traffic signals, two different poles of the traffic signal, are all communicating the same message, that left turning is separate and straight is separate. Okay, so redundancy can be within a device or it can be by use of multiple devices. Okay, some of the redundancies here, okay, for different signs and markings and so on. Okay, you can go through it. So now moving back to the traffic control devices, we have three types. The most common one of them, the most often used, is traffic markings. So anything which you see on the pavement or near the pavement is a traffic marking. They can be of three types: longitudinal, transverse, and object markers and delineators. So longitudinal is something which is along the pavement. Lane marking, shoulder marking, okay, center line marking, pavement edge marking, all these are longitudinal. Then we have transverse, which goes across the road. Okay, which goes across the road. So this can be for stop line, for pedestrian crossing, for parking, all these types. Then we have object markers and delineators. So object marker, this one is the object marker and this one is the delineator. The top one is the object marker and this one is the delineator. Okay, so you can see object marker is on this object. Okay, so it's an object which I want to warn the driver about. This is an object on the road, I want to warn the driver, so I put a marker here. So driver can see from far that there is an object. And delineator is just before the object. So delineator tells the driver at which point he or she should start to separate in directions. At which point he should move from his path. Okay, so delineator, so there is an object here. So before I reach the delineator, I should start moving away from the object. So object marker tells you that there is an object. Delineator tells you when you should start getting away from the object. Okay, both of them you can see are not exactly markings. This is not a marking, this is not a marking. Okay, these are objects which you put on top of the pavement, but the objects are so small, these are small objects, so we are counting them with marking. They are not purely markings, you can see that, but because of their height, the height is very, very low, so we consider it under instead of making another category, we consider them under the category of pavement markings. Then we have traffic signs. Traffic signs can be further subdivided into three types: regulatory, guide, and warning signs. Regulatory signs are those which tell you about a traffic regulation. If you don't follow them, you will have to pay the fine, and they are related to your safety directly. Warning signs, they inform you about a hazard on the road. You can see this one informs you about a very sharp curve and tells you what to do. So they are directly related to safety. And then we have guidance signs which tell you about the nearby locations, directions. Okay, so where is the gas station, where is the hospital, where is the bank, where is the next city, where is the if you take a left turn, where will you reach, right turn, where will you reach, and so on and so forth. Okay, so these are guidance signs. They are for information of the driver. They have nothing to do with the laws or safety. Yes, if you look at these signs, then you may be able to drive better and you may improve the traffic flow and safety overall. Okay. Then we have traffic signals. Traffic signals can be of 9 types. Okay, we have the usual one, the one which you see at the intersections. We call them traffic control signals. Then we have the other ones which are installed for pedestrians crossing the road. We call them pedestrian signals. Then we have ones which are for emergency vehicles. So near the hospitals, for example. So there's a intersection near the hospital which usually has a roundabout or which is without any sign or signal. But when the ambulance passes, the signal starts operating. Okay, so it's a signal with a sensor and the sensor attached to the emergency vehicle. The emergency vehicle approaches, the signal starts working. Otherwise, either it is working normally or it is not working at all. So we only stop the other directions when there is emergency vehicle. Then we have one lane two-way facilities, signal for one lane two-way. Okay, so what does it mean? You have one lane. Okay, so there's one lane. I can enter from here, I can enter from here. If you allow both of them at the same time, you will create problems, accidents, and traffic blockage. So what we do is we put a signal here and we put a signal here. Okay, each one of these signals will be green at one time and the other one should be red. So if this one is green, this one should be red, and vice versa. Both of them cannot be red, then the street is useless because nobody is entering, and both of them cannot be green as well because this will create a lot of problems. So in this way, you make one street safe for both directions. So it's a one way, one street. It's a one way, one street at a time, but you are managing it with a signal. Okay, so this is for one lane, two way facilities. Then we have traffic control signals for freeway entrance. We also call them ramp meters. So you have a highway, and with the highway you have a ramp. Okay, so people are entering from it. So you may put a signal over here to control the flow which is entering from the ramp. This is a one-way signal only for the ramp. You don't stop the other direction at all. Okay, so this is the difference between this one and the normal ones which you have at the intersection. At intersection, we are covering both or all directions with the signal. But on ramp meters, you are only controlling the flow from the ramp. Okay, so you can make it with a sensor, you can make it without sensor, but the point is, flow from the ramp should not stop the flow on the highway. Okay, so if it becomes too much from the ramp, like we see in the morning peak hours, then you want to keep the highway less affected. So there is a signal. Even if many vehicles want to enter from the ramp, they will have to follow the signal. Then we have traffic signals for movable bridges. Okay, so in some countries they have roads on rivers, and those roads have these roads are on bridges. Okay, and under the road there's a river, and from the river ships are passing. Okay, so the ships can have a lot of height. Okay, so in some cases what they do is, so this is a bridge, these are the two parts of the bridge, and there's the ship which is coming. Okay, so when the ship wants to pass, they close the bridge from both sides with a signal. So they make both sides with a red signal. Okay, when the bridge will open like this. It will create a space for the ship to pass. When the ship passes, the road will get back to the normal position. The signals will become green, both of them, and then you can allow the vehicles to pass from the bridge. Okay, so we have these sort of bridges in Amsterdam, in London, and there's some city in Italy as well. So they are there. So they are there when the river is moving through the city itself. Then we have lane use control signals. Okay, so we have multiple lanes here. Okay, so what we normally see here is what this lane is for straight and right. This lane is for straight and this one is for left. It will remain so in the whole day. Okay, the lane which is for straight will remain straight for the whole day. Okay, we don't change it. But what if I need an extra lane for left turning in the evening, because left turning traffic is too much in the evening? So what they do is they don't make the lane assignments as fixed. They put signals on it. So when I'm coming towards the lane, I have to look at the signal and I will know this lane is for which movement at this time. So in this way, we can increase the number of lanes for one movement which requires more lanes, which has more traffic. So these are lane use control signals. Then we have flashing beacons, which are used for warning. Okay, something like this. So these are flashing signals. They flash and they warn the driver that they should go slowly from here. From this place, they should go slowly. So these are called as flashing beacons. So they are signals which are flashing constantly and they are providing warning to the driver. Then we have in roadway lights, which are these ones. They are used with pavement markings. They are used in places where lighting conditions are not so good. The weather is normally dark, okay, and so on and so forth. So there you use in roadway lights to enhance the visibility of pavement markings. Okay, we will discuss a lot more about traffic signals. Some more couple of more points about traffic signals. Traffic signals are considered as ultimate traffic control. On an intersection, traffic signals is considered as an ultimate traffic control device. Okay, so that means I cannot remove it and I cannot use it with something else. I cannot remove it, I cannot use it with something else. Removing it means switching off. So signal is there, but it's not working. It's the same as removing it. So we don't remove it and we don't switch it off. Okay, if you do this, any of these, if you use it with some other device or you switch it off, you are creating confusion for the driver. So there was a signal at this intersection. Now I'm coming here and the signal is gone. Intersection is still there, and so I'm not talking about removing the signal and putting a bridge there. When you put the bridge, intersection itself is gone. Okay, but you are keeping the intersection and you are removing the signal only, or you are switching off the signal only. This will create confusion for the driver. I came in the morning, signal was working, I knew when to move and when to stop. Now no signal, I don't know what to do. Okay, or you use it with some other device. So the signal is green, but there's a stop sign there as well. What am I supposed to do? Okay, it creates confusion. So we should not do it. If signal cannot be used properly, at least use it in the flashing mode. So I told you, flashing signal means what? Warning. You can use it in this mode. Now there are specific benefits which you get from the signals which you cannot get from any other control device. For example, compared to the other control devices, which you use at an intersection, signal capacity is higher compared to the others. So if you are comparing signal with a roundabout, with a stop sign, with a give way sign, signal capacity will be higher. Okay, but obviously you cannot compare a signal with a highway. Highway capacity will be higher, obviously, but you are comparing with something which is similar. Signals, obviously, when you are allowing different vehicles to move at different times, you are controlling the frequency and severity of the crashes as well. Most of the crashes which are conflicting, they do not happen at signals. So this type of a crash will not happen. And this is a serious one. Similarly, this one and this one. This is a serious one. So these serious crashes are eliminated with the signal. There can be minor crashes, for example, crashes which happen like this, side swipe. They can still happen. Crashes which are rear end, they can still happen, but their severity is less. Normally, these crashes do not end up in serious injuries. Okay, so we are controlling the serious ones here. And it gives a chance for pedestrians to cross safely as well, because vehicles are completely stopped. If you use signals on intersections which are close to each other on a highway, you can program them together to move without any interruption. So this is the highway, there's signal here, and signal here. I want this traffic to move continuously. So I'll make this signal green. After some seconds, this one green. After some seconds, this one green. Okay, so when the vehicles move from here, they reach here, this is green, they reach here, this is green. So they move continuously. So this sort of continuous movement can be programmed using coordinated signals. Signals also provide enough opportunity for minor road traffic. I give you the example of ramp. Okay, so if the traffic on the highway is too high, people from the ramp will not get a chance to enter the highway because they don't find any gap. Same thing can happen on a roundabout. Same thing can happen on a stop sign. Okay, yeah, I'm on the minor road, I'm stopped. So I'm looking for a gap, but the other direction has so much traffic, there's no gap available for me. So I will keep on waiting and waiting. And same thing happens with the pedestrians. Vehicles are coming at very high speed and there's no signal, so they are not stopping for anything because they know if they slow down, somebody will come from the other side, so they don't slow down. This is very dangerous for the pedestrians. Okay, so signals help you in those cases as well. We know signal indications, right? Green, yellow, red. Yellow is the one which is before red, more critical one. Okay, the most critical yellow is the one which is before red. So you see the signal is green, then it becomes yellow, then it becomes red. This one is a critical one. We use another one as well, the one which is after red. This is not critical because your car is stopped and the other directions also stop before your signal becomes yellow. So it's in an all stop mode. That yellow which is after red, it is in an all stop mode, so it's not important. The important one is when one direction is having green, then goes from green to yellow, so that one direction is moving. Okay, so you are asking the moving drivers to slow down. That is more critical, that can be more dangerous. So that yellow. Then we have flashing ball. I told you flashing. Okay, now you can see they are not saying green light, yellow light, red light. They are saying ball. It's a term which they use in US because of the shape of the light. They call them balls, but it means light. So flashing ball means a flashing signal. Now if you want to use the signal in a flashing mode, we either use it flashing yellow and flashing red. Flashing yellow means slow down, flashing red means stop and go. Okay, so flashing yellow is same as give way sign and flashing red is same as stop sign. Then we use it when signal cannot work properly. Okay, sometimes we can use it in night conditions. In night conditions the traffic is very low. I don't want to operate the whole signal. There's one car coming after like 40-50 minutes. So why should I have the whole signal working? So I can keep it just flashing. Then we have sometimes the signal with arrows. It shows that this signal is for a particular direction. So when the signal becomes green in front of you and you don't see any arrows in the signal, that means from this direction I can go right, left or straight. But if you see the signal is green, but inside the signal there's a upward arrow, so that means this signal has only become green for straight traffic, right? If I see a left arrow, that means this one has only become green for left turn traffic. Okay, so the arrow signs indicate if the signal is for a specific direction or not. Okay, so I'll stop here.